Okay, let's try this video for a third time. I'm using a different screen recorder because I don't like the one the school set up for us. Polygon, side vertex. You can get all those from right down in this area down here. Polygon is a closed plane figure formed by three or more line segments called sides. Three or more, that means it's a triangle or more sides. It can't be open like this. That's what it means by closed. It's got to connect all the sides. It can't cross over like this one right here. Those aren't polygons. Couple of examples. Sides, the segments that connect the vertices. Vertices, the point where the two segments meet or intersect. Just like an angle. An n-gon, an n-sided polygon. So a 15-sided polygon would be a 15er-gon. Now there are some names you need to know for these. These are listed on page 30 in your book. Okay, so you need to know that a triangle is, three-sided polygon is a triangle, a five-sided is a pentagon, 10 sides is a decagon, 12 sides is a dodecagon. All those names on page 30 you are expected to know and have memorized, so don't miss those. Convex polygon, when no line containing a side contains an interior point. So what they're talking about here, you look at this side, it doesn't cross into the interior. This side doesn't cross into the interior. This side doesn't cross into the interior. The line containing this side, so I'm just drawing lines containing the sides. None of them cross into the interior, so that is a convex polygon. Okay, concave is not convex. One way of thinking it is caved in. That means a side does cross into the inside. So if I look at this side, so it looks like this side's been sort of caved in. It kind of looks like this side has been caved in an accident or something like that. That's one way of, Mr. Durbin likes to remember it. But if you look at this line containing this side, you can see it goes to the inside of the shape, as does this one right here. That's the formal definition. That makes it concave. Yes, I definitely like this program better. I can control it and pause it a lot easier than I could the other one. You can name a polygon by listing the vertices in consecutive order. That means you got to go clockwise or counterclockwise. So they called this A, B, C, D, E. So that's A, B, C, D, E. Okay. Pretty basic. You could call it C, D, E, A, B, C, D, E, A, B. That's going clockwise. I could call it B, A, E, D, C, B, A, E, D, C. That's going counterclockwise. I couldn't do B, D, A, C, E because B, D, A, C, E. You can see that's going across it. You got to be going around the shape in order. Something in here about a side can't, two consecutive sides can't form a straight line. So you can't have like another point right. You can have a point there, but you couldn't call that point K a vertice on that. So you can't have, two consecutive sides forming a straight line. I remember reading that in here somewhere. I don't remember where right offhand. Okay, straight into the extra practice. Not a lot of notes in this section. Again, you got scrambled answers over here. Let me erase some of these lines before I forget these extra orange lines. I don't want to forget. So, classify the polygon. That means name it by the number of sides. Tell whether it is convex or concave. Okay, so we're classifying it by the number of sides, convex or concave there. So this one I got 1, 2, 3, 4, 5, 6, 7, 8 sides. Well, 8 sides is an octagon. So I've got an octagon, and this is going to be concave because I can see this line right here that contains that side crosses to the inside. It looks like it's been caved in from the top. So I have octagon and concave. And And over here, octagon, concave. There's my answer. That checks out. Number 4, same sort of thing. This is a special polygon, which doesn't mention this is called a regular polygon. All the sides and angles are congruent. Definitely looks like it's convex to me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can see none of these sides cross in there. So we got 12 sides. That's a dodecagon, and it's convex. There's our answer. I probably should have written it down. Dodecagon. And convex. Circle my answers. I forgot to. There's the first couple there. Okay. Find the perimeter and the area. Okay. So a few different ways we can go about this. You can plot these. You can put the points in there. They got 2, 4. Z is 2, -2. They talk about, geez, x to z. The x coordinates are the same. I can just say xz equals absolute value 4 minus -2. That's absolute value of 6 for a distance of 6. Okay, I could have also just counted that out. I could have gone, okay, this is 1, 2, 3, 4, 5, 6 going down there. Either way is fine. You could use the distance formula too. This method is actually an adjustment of the distance formula for the vertical one. So I get 6 right there. I get 2 right there when I check it. This looks like it's been slightly moved off its marks here. I don't know why. Everything looks like it's been slightly moved. So I got my lineups fixed on here. Notice you do have to, except I didn't get the vertical lineup fixed. So now to get the perimeter, I need to get this XY segment right here, which is on a diagonal. I can't get it easily like I got the XZ or the YZ or the XZ. So I'm going to have to use my distance formula. I've labeled my points. I'm going to get my pen running here. Let's go with this color. That's what we've been using. Okay, so I'm going to have xy equals square root x2 minus y2. So that's going to be 2 minus 0 squared plus 4 minus -2 squared. That goes to 2 squared plus 6 squared, which is 4 plus 36, which is square root of 40. And I got to look this up on the calculator, which comes out to about 6.3. Sorry, that's so small. But it is what it is, unfortunately. So over here, so I got 6.3. So my perimeter, I'm going to have 6 plus 2 plus 6.3, and that should be an approximate actually. That's going to give me 14.3, and that's going to be units. Okay, my area, I don't need this 6.3, 1/2 base times height. I know this is a right angle. I got a vertical and a horizontal line, so that's just 1/2 times 2 times 6. These bigger for you. That reduces to 1 and 1. That just leaves 6. It's area, so it's units squared. Let's check it. 14.3 units, 6 units squared. Notice those two answers are together. Number 6, this is our altitude right there. It's not drawn in the picture. You got to put it in there. I'm going to show you how to do that in another problem a little later here. Okay. Down here, notice these axes aren't centered. So sometimes you got to pay attention to where the axes. And what I notice here is like, hey, we got these 6s. When I'm in the center, I can get 1, 2, 3, 4, 5 to either side. But I got a 6. I want it to be on the grid. So I'm going to move my y-axis a little to the left, because when I move that y-axis, it's actually going to change the x numbers. Now I'm going to have 1, 2, 3, 4, 5, 6 in there. I got room for that 6. Same thing over here. I had some negative 6s showing up in the y numbers, so I had to raise my x-axis here to make sure I had room for that negative 6 on there. So that is something you need to look out for on these problems. So perimeter of ABD, similar like we did before. So here's ABD right there in the orange. Not hard to get. This is 5 over here. 1, 2, 3, 4, 5. 4 minus negative 1 is 5. Negative 4 minus 2 is negative 6. Absolute value is 6. I need to find AD. Again, that's distance formula. So that's going to be square root. I don't like my numbering. Negative 4 minus 2 squared plus negative 1 minus 4 squared. That gives me negative 6 squared plus negative 5 squared, which equals, where am I here? 36 plus 25. Write that a little better here. Which equals square root of 61. Which is approximately second square root 61, close my parentheses, 7.8. And so I get 5 plus 6 plus 7.8. That's 11. That's going to be about 18.8 units. And again, that should be an approximate since there's a rounding in there. There's an 18.8 units in my answer. So next you're going to find the perimeter for, I'm running quick on time here, this one right here, ABCD. Then they want you to find the perimeter of quadrilateral ABCD, which is the outer one right here. My question is, do you add up 9 and 10 to get the answer to 11? Think about it. Pause if you have to. The answer is no. This line here, it's included in both those perimeters. It's not in the perimeter of ABCD, the outer shape. Whoops. Sorry, we had a little crash there. Why aren't we working here? And it's still not working right. Okay, so we had that. And again, you don't add the perimeters of the two parts because that BD segment isn't in both. Find the area of ABD. Okay, so that's this one right here. This piece, 1, 2, 3, 4, 5, we said this was 6. Our height is going to be this piece right here. Whoops. Even though it's not drawn in there, we got to put it in. That's got a height of 4. Okay? So to find the area of BCD, I got to shrink this down a little bit here. Area of that triangle BCD equals 1/2.6.4. That's 3. That comes out to 12 units squared. We can see the answer right there. I've only got a couple of minutes left less than a minute left on this video. So number 14 to 12 and 13 add up to 14. So when I find the area of ABD, that top triangle, and the bottom triangle, does that add up to the big area, quadrilateral ABCD? In this case, that is a yes. So area we added up, perimeter we didn't on this because the perimeter included a piece that wasn't the outer edge. We're out of time. You all have a good day.